Okay, for Project 4 Part 2, we're going to be looking at the relationship between a derivative of a function and the slope of a tangent line to points on the graph of the function. So what I did is I created the parent function of x cubed. So we have 1x cubed plus 0x squared plus 0x plus 0, and our graph just looks like that. Okay, you can see the graph in the upper left window if you create this in GeoGebra. Okay, and we also created a point A, which I currently have at 1, 1. I just set the x value, and on the graph of x cubed, if I put it at x is equal to 1, well then y is going to be equal to 1 as well. Okay, we also created a point D, which we're going to use in a second, but what we want to do is we want to look at what is the relationship. Well, in calculus, the derivative of a function is the equation of the tangent line to that function. So you notice we also created a tangent line that goes and passes through point A. Okay, so why does that tangent line, according to our triangle here, have a slope of 3? Okay, well, if you take the derivative of x cubed, the derivative, of course, is going to be 3x squared. Okay, by plugging our value of 1 from our point A into 3x squared, of course 1 squared is just going to be 1, so 3 times 1 is going to be 3. So automatically tells you what the slope of the tangent line is going to be passing through point A. And it would work for any value. And what we're going to do in a moment is demonstrate by moving point A up and down the graph. Okay, but I want to show you this before it. So just like our previous project, you can take the sliders and we can go ahead and move this. Now you notice how the point is moving with it, but it's still an x value of 1 because that's what we put in. So we're not really moving the point as far as its x value goes, but the point is moving along the graph as we change it. Okay, if we change the b value, you're going to see you get some actual change in slope. Since the original function just has a positive slope, now we have a positive, a negative, and a positive again. Okay, so we have a min and a max. If we change the c, okay, we're going to once again go to where we just have a positive slope by increasing the c. Decreasing the c, of course, is going to change it to where we have more min and max, and then d, of course, being our constant, is not going to affect the change, or not going to affect the shape, I should say, but it's just going to move it up and down the y-axis in a vertical shift. Okay, so we'll reset these back to the standard, and we'll show the relationship between the derivative and the slope of the tangent line. Alright, so everything is reset. What we did is we created a point, and that point is point D. Now it's not an independent point, it's dependent. And what D is it is the x value of our point A. So you see that if A is 1, then D is going to be 1. But the y value of point D is going to be the slope. And we have the slope of our tangent line here, represented by m. So as point A moves, if I move A along our graph of x cubed, it's going to, of course, change point D. And it's also going to have the slope, the y value is going to be the slope of the tangent line to point A in our graph. Okay, so it's a little bit different, but what we're going to do is show you what the derivative looks like. And as we said, for anybody who's taking calculus, the derivative of x cubed is going to be 3x squared. Okay, so the derivative, oh, there you go. The derivative is going to be our parabola 3x squared, okay, which is demonstrated there. And of course you can tell when x is equal to 1, y is equal to 3, it's 3x squared. Okay, now if we graph our point D, point D is going to lie along that line, because currently if it's the x value of A and it's the slope, which is 3, okay, then it's going to be at a point 1, 3, which lies on our derivative. Now if I take A and I move A along here, you're going to notice that as A moves, the slope, of course, of our tangent line is going to change because I'm changing the x value that gets put into it, that gets put into 3x squared. But watch point D because it's dependent on it. Okay, as a moves along and becomes 0, well then our point D is going to be at 0 and it's going to have a slope of 0. And as I continue to move along our x cubed function, D is going to perfectly trace our derivative. Okay, so no matter where I move A along that function, let's say we change the graph a little bit, make it a little bit more interesting. Okay, let's once again graph our derivative and our point D, but let's change, we probably want to do that after, let's see. Okay, let's change our values here first. Let's go ahead and alter our A, B, C, and D. Okay, still a cubic function. Now if we graph the derivative, of course our parabola is moved. If I graph point D, currently point D is going to be off, but as I move A it should come onto the screen. So now we move point A, and you're going to see point D comes in, and of course even though we don't have the parent function anymore, as A moves along, D is going to graph our derivative. Okay, so again, for those who aren't as familiar with calculus basics, the derivative is just merely the equation of the tangent line. So we can always tell what the slope is at any point on a graph if we know what the derivative is.